Hello, I'm Dr. Papia Bhattacharjee. Hi, in the last two videos, we have figured out what will be the relative extrema and inflection point to the graph of this function. And now we will see if we can figure out there are any asymptotes to the graph. So let's talk about vertical asymptotes. Now, how do we compute or figure out whether the graph will have one? Look at the function expression, x over natural log of x. You know that vertical asymptote happens when the denominator of the function is 0. So the denominator is natural log of x. So question is there any place where natural log of x is 0? And yes, there is. I mean, we can solve this equation using the property of exponent and natural log. And you know that the solution will be x equals the base e to the power 0, and that is 1. We know that natural log of 1 is 0, so x equals 1 is a solution, and therefore x equals 1 is a vertical asymptote. All right, so let's write that down here. Now we have to figure out how the function behaves around this vertical line, x equals 1. So what happens when x is approaching to the 1 from right side and from left side? We also know that the function will approach to infinity or negative infinity. Question is which one, positive or negative? So let's analyze that quickly. So x is approaching to 1, say from the right side of the function x over natural log of x. We know that the denominator will be going to 0, so this will be going to infinity or negative infinity. All we care about is the sign. So the best way to figure out the limit is pick some value to the right side of 1. And what's the best value to pick? Let's pick, say, e. Because we have natural log, we know what the value of natural log of e is. So say if you plug in x equals e, what happens to this numerator? Well, it's a positive quantity, right? This is just e. What happens to the denominator? Natural log of e. So this is natural log of e, and that's 1, and therefore this is positive as well. And so this whole thing will be positive and positively increasing, and therefore the limit is going to be positive infinity. Now, what about the left side of 1? So what is the limit x approaches 1 from left? Now you can do the same thing again. Pick a point to the left of 1. What point should we pick? Well, let's pick, say, x equals 1 over e. That's a number less than 1. And notice that when you plug that in for x, the numerator is still positive. That won't change. Now what about the denominator? So this is natural log of 1 over e. Now you can apply the property of natural log. Remember, natural log of a quotient is just natural log of 1 minus natural log of e. Natural log of 1 is 0. We just solved it here. And natural log of e is 1. So you see this is negative. So this is a negative number. So the entire quotient is going to be negative. So this limit will be negative infinity. Okay, so when we graph, we need this information to graph it. So let's write that down here as well. So limit x approaching 1 plus is going to be positive infinity, and limit x approaching 1 minus is going to be negative infinity. So that's the information we need about vertical asymptote. Finally, let's talk about horizontal asymptote, if there are any. Okay, so how do we compute horizontal asymptote? This is where we look at the limit of this function, x over ln of x, as x is approaching to either infinity or negative infinity. Okay, so what is happening here? X is approaching to infinity. Is the function approaching to any value? Note that natural log is an increasing function. So as x goes to infinity, natural log will be increasing. But x is also an increasing function. So they're both increasing, right? So it will be like an infinity over infinity. So how do we know what is the value? Is there one? Is the whole thing increasing? Well, if you just quickly notice that the line y equals x, you know what that looks like. It's right here, if you graph it. And natural log, you also know, have an idea of what the graph of natural log of x is. It's increasing, but it's increasing something like that. So here is x, here is ln of x. So which one is increasing faster? Of course, the top one, the x. This is over ln of x. So even though both of them are increasing, the numerator will be increasing faster. And so this whole thing will go to positive infinity as well. This entire function is increasing. All right, so that's one of them. So there is no horizontal asymptote because function will be increasing as x is increasing. What about negative infinity as x approaches to negative infinity of the function? Now think about it for a second. This means x is taking large negative values. So what is happening to the function? Well, we already have said at the very beginning that this function is only defined for positive x. So there are no values of the function when x is approaching to negative infinity. So this limit will not give us anything. There's nothing there to consider, right? So we have no horizontal asymptote. Okay, so no horizontal asymptote. And we also know that this limit as x is approaching to infinity of the function, that is going to be positive infinity. We will use this fact to graph this function. All right, so we have all the information that we need, and we just have to now graph the function, which we will do in the next video.